again. I am with the next video part that we were solving the JEE Mains 2024-2025 session papers. So in last video we have solved the 22nd January morning shift paper. So in today's video we will be solving the 22nd January evening shift paper. So let us proceed. So 22nd January evening shift. That's morning. That's so the same thing. Many teachers, they have already made the videos, they have already solved, but in our video we will be solving the tricks and concept, both, mixture of both, because too many questions are there in which we can use both things collaboratively. Like we can use the tricks, we can use the concepts, and in many questions we need to only check only one option that will give you the answer. In some of questions we have to solve all four. So many things are there in this video once again. So let us start with the first question. So the first question here, one more thing, I'm solving the questions online mode because we can cross check the answers. So whatever the right answer is there, we can check, we can click and we can check the answer. So the first question is, when secondary butyl cyclohexane reacts with bromine in the presence of sunlight, the major product is. So first of all, what comes to your mind when it is sunlight? Sunlight means it is free radical mechanism, and if it is a free radical mechanism means it will be going via carbon free radical. So if you know the stability of carbon free radical, that can be explained by hyperconjugation. Hyperconjugation means we can calculate alpha hydrogens directly, so no need to go anywhere. Just no need to do any reaction. You need not to write what is secondary butyl hexane. I'll show you in the options. No need to write the reactant. Just check the options. How? Just check option number 1, option number 2, option 3, option 4. All have the common structure. You only need to check the number of alpha hydrogens. So in the first structure, if I calculate the number of alpha hydrogens, so it will be, according to this, 1, 2, 3 alpha. Next we have got 1, 2 to 4, 5 alpha. Here we have 5 alpha. Here we have 3 plus 1, 4 alpha. And here we have 1, 2, 3, 4, 5, 6, 7, 8 and 9 alpha. So I think you have got the answer. More the alpha hydrogens, more is the stability of 1, 2, 3, 4, 5 and 6 alpha, not 9, 6 alpha. This is the beta position. So more the alpha hydrogens, more is the stability of the product. So we can calculate. So let us check the answer. So option D is the correct answer for first question. Next, two statements are there. Given below are two statements. Corrosion is an electrochemical phenomenon in which pure metal acts as anode and impure metal acts as cathode. If you remember the electrochemistry, we have seen that the pure iron gets corroded. That is called rusting. Its oxidation occurs, means pure metal will act as anode. Definitely it will act as anode. Why? Because oxidation occurs at anode and reduction acts at cathode. Means statement 1 is right. The rate of corrosion is more in alkaline medium than in acidic medium. More in alkaline means in basic medium the acidity is more. That is a wrong statement. Corrosion is always more in acidic medium. So statement 1 is true and 2 is false. 1 is true and 2 is false. So that's how you got the answer. Right? So just it will not take more than 30 seconds to think and solve this question. This is how you can solve the questions. Next question, the most stable carbocation from the following is, stability of carbocation is directly proportional to mesomeric plus M effect, hyperconjugation plus H and inductive effect. So here check. And secondly, if it is a benzene, then the stability at ortho para then meta, it is more, it is less. Cross doesn't mean it is not a stable carbocation, but it is less. So if you check here, in this case, according to this carbocation, it is attached here. This becomes the meta position, means A is not our answer, right? Then go for, this is methyl group, This methyl give you plus H as well as plus I, and plus I, both it will give, and secondary it is at para position, means it may be our answer. Then again, yes, MEO, it is called methoxy. Methoxy has high minus I, but high plus M effect, because oxygen is having the lone pair. Oxygen is having the lone pair, it can go to resonance and it can stabilize this carbocation. So it may be the answer, means if I compare B and C, then C is more stable. Why? Because it shows plus M, and B, it shows only hyperconjugation. And if you remember the effects, most stabilizing factor is the mesomeric effect. Second number stabilizing factor is hyperconjugation. Third number is inductive effect. So C is more than B. Let us check the fourth option also. Okay, only the benzene ring is attached with the carbonate, so definitely C is our right answer. So this way we have got C as our right answer. So this is how you can solve. Next, the correct order of the following complexes in terms of crystal field stabilizing energies is, okay, 1, 2, 3, 4 are given. Let me check if all the compounds are same or not. Okay, fine. So if you remember, the stability of complexes, stability is directly proportional to denticity. What is denticity? Denticity means the number of bonds it is making. So we have got a bidentate ligand here. Bidentate ligand here means it is showing the maximum energy. Definitely this option and these options, they are already eliminated. Right? So it will not take more than 10 to 15 seconds to recognize that these two options need to be left out. Then we have oxidation number +3, +2, +2. After the denticity, second factor that we decide is from oxidation number. So it is right. Then we have +3. Here we have +2. Means this is also not our answer. We got our answer. There is a trick for calculating the stability. CFSE has goggles. I have taught my students. CFSE means crystal field stabilization energy. Then we have to check the denticity. Then we have to check the oxidation state. Then geometry. If we go for geometry, then square planar, octahedral, then tetrahedral. But before that, the bigger factor is the oxidation state. So we have gone by this thing. So let us check the answer. A will be our right option, because B and D already gone, because the denticity is here, the bidentate ligand is at last. Here bidentate ligand is at second. But in this case, the oxidation state, it is at third position. So let us go for the first option. That is the right answer. This is how you can solve, like 20 seconds, maximum 20 or 30 seconds. Next, maximum covalency of a non-metallic group 15 element with weakest EE bond. What is group 15? Write in the comment box. Group 15 is nitrogen. The concept behind this is, now students got confused in this case, because it is EE bond, single bond. Nitrogen always make a triple bond, N2, most stable. Then phosphorus, and then we know that when we are moving down the group, the triple bond, that the overlapping of pi orbitals, it is not stable. Why? Because the size is increasing and the orbital, it weakens, due to which the pi bonds, they are not getting stabilized and the bonds gets dissociated. Hence we are talking about the single bond. Now nitrogen, due to its small size, the electronic repulsion is there, because the atoms, they are close to each other, due to which there is a repulsion. So weakest EE bond means we are definitely talking about nitrogen, not phosphorus, not arsenic, not antimony and bismuth. We are not talking about this. We are talking about nitrogen, because it is a non-metal 15, group 15. Top to bottom, non-metallic character decreases, metallic character increases. We already know this thing. So for nitrogen, what is the electronic configuration? It is 2s2, 2p3, so like this. So what is the maximum covalency of this nitrogen? That is 4. So let us go with the option number C. Secondly, it is a memory based question. Whenever we are writing notes, we write this thing, that the covalency of nitrogen is this much, sulfur is this much, oxygen is this much. That is, you can also do it by memory, or you can do it solved by concept. Next, students, we have the number Identify the number of structures from the following which can be correlated to D-glyceraldehyde. Always remember from biomolecule, if you remember, for the conditions of writing D-glyceraldehyde, first condition, CHO group should be on top position. Secondly, the second last OH should be on right hand side. The two conditions are there if you want to write the D-glyceraldehyde. So CHO should be on top. So if I talk about this thing, then OH, second last OH, means this is definitely, this structure I can draw like CHO, OH, OH, H, H, and it is OH. OH means H and H. So it is CH2OH. Like this we can draw all these structures. Okay. So this thing, second last OH is on right hand side, means it is D. Second last OH is on right hand side, means it is D. The OH is on left hand side, means it is L. Now CHO group here, it is at the bottom. So we have to rotate this molecule 180 degree. If you rotate this molecule 180 degrees, CHO will go on the upper side. So the OH, this OH, if it is present on left hand side after rotation, definitely it will come on the right hand side. If it is right hand side, means it is again D. So total number of D-glyceraldehydes from this question we have got are 1, 2, 3. This is not. So we have got 3 structures similar to D-glyceraldehyde. I guess we have got the right answer once again, right? So next we are moving towards the next question. Qualitative analysis. Always remember, in every shift of JEE, you will get one question from qualitative and quantitative analysis. Sometimes they are giving you this type of question like Lezines extract question. Sometimes they have given you the Carius method. So many questions from Carius methods have came. In the last 2 years, I guess, there were more questions from Dumas method and Jaldahal's method. This year, the NTA is preferring Lezines extract as well as Carius method. For next year, it may be again Duma and Jaldahal. We can predict only, we are not sure for that. So, nitrogen, sulfur and halogens and phosphorus present in an organic compound are detected by Lezines test. Exactly true statement. Because Lezine test is done for them. They are converted from covalent to the ionic nature. So, statement 1 is true. The elements present in the compounds are converted from covalent form into ionic form, true, by fusing the compound with magnesium, not magnesium. Which compound we are using in place of magnesium? We are using sodium. Means statement 1 is true, but statement 2 is false. Memory based question. Statement 1 is true, 2 is false. So we have got this answer. So this maximum questions are from NCERT level. This is NCERT level question, right? Next, activation energy. Choose the given figure and choose the correct option. Okay, the reactant energy is there, product energy is there. Reactant energy, product, it means if I go for energy, energy of product is more than energy of reactant. That means stability of reactant is more than stability of product. Okay. Now the total energy E1 to E2, it will be total energy is equal to ET is equal to E1 plus E2. So these are the observations that I can get from this graph. So let us see what are the options. Activation energy of both forward and backward reaction is E1 and E2, and reactant is more stable than product. Reactant is more stable than product. That is fine, but it is not equal to for both forward and backward reaction. That is the wrong option. Activation energy of forward is E1, E2 and product is more stable. Okay. The forward reaction is E1 is E2. That's fine. But product is not stable. Product is unstable because it is having high energy. B is not our option. Activation energy of backward reaction is E1. Product is more stable. Then again the thing, this is right. But product is more stable than reactant. It is wrong. Because energy of product is more than reactant. Activation energy of forward reaction is E1, E2. Fine. And product is less stable than reactant. You have got this thing. Why? Because the energy, whenever we are talking about the stability. Lesser the energy, more the stability. If someone is not eating for 1 week and he moves, that means the energy is drained out. So stable things always have less energy. So option number D. That's again the right answer. Next, moving towards the dipole moment. No need to. Now trick and concept. I will go via trick. What is the trick? We have memory based. We have studied that the dipole moment of NF3 is very less, and dipole moment of CH3L3 is very high. If you remember in chemical bonding, there is a rule that if the subsidiary atoms are more electronegative than the central atom, the overall dipole moment of that compound decreases. In NCERT, we have a comparison between ammonia and NF3, right? So if I go via this thing, these two, CHCl3 should be maximum and NF3 should be minimum. CHCl3 should be maximum means D option is cut out. Then NF3 should be minimum means this is cut out, this only C we have got the right answer. 20 seconds, memory based question, NCERT level question from NCERT. I guess C is the right answer. We have got this question right. Okay, so moving towards next question. Density of 3 molar NaCl solution is 1.25 gram per ml. The molality of the solution is. You can solve this question via two methods. First method is write the formula of relation between molarity and molality. You can solve by this method, but an alternative option is there to solve this question. That is very easy. How? What is the formula of molality? You have to find the molality. Molality is number of moles upon weight of, it is number of moles of solute upon mass of solvent into 1000. Now I have a 3 molar NaCl. 1 mole NaCl means 58.5 gram. So it will be 3 into 58.5. So let us multiply 58.5 into 3. 5 3s are 15. 1, 24, 25, 2, 15, 175.5. So it is 175.5. What is this? This is the mass of solute particles. 175 gram 5. Now the density is 1.25 gram per ml. Density 1.25 gram per ml. If I convert this thing into liters, then it will be 1.25 into 1000. Conversion everyone knows. So it will be 1250 grams total mass of solution. So if I want the mass of solvent, I have to subtract solution minus solute. So 1250 minus 175.5. Let us subtract 1250 minus 175.5. So it will be 5, 4, 7, 107.4. Okay, let us solve this question now. I think the color, all these are calculation. So molality is equal to 3 upon 1074.5 into 1000. In previous video, I have told you how to do the calculations directly. Now how you can solve? Look, molality becomes 3000 divided by 107.4. Am I right? Now we know 30 and 10 is approximately 3. But it is 74 means it is not 3. It will be 2 point something. 2.5, 2.6, 2.7, 2.8, something 2 point. So if we have got the option 2 point something, then that is our right option. This is gone. This is gone. This is again gone. Why? Because 1074. If it was 1000, we would have got the, if it was something like 2000 upon 1000, we would have got the right answer. So means definitely we have got option A. That is the right answer. These are the methods how you can solve this question. Or you can directly apply the formula. Okay, next question. The molar solubility of zirconium phosphate with molecular formula Zr4 plus thrice PO4 thrice 4 is given by the relation. If someone have solved the previous year question, this question is from NEET. I forgot the year 2022, 2023 something. But this question has been repeated from NEET with something changed. Indeed, they wanted to ask the KSP. They asked the KSP only. Now, how to solve this question? We have got 4 and 3, 4 plus 3, 7. Right? If you remember the formula, x raised to power x, y raised to power y, means this is wrong, this is wrong. We have got this and we have got this. Now, rest is just multiply. 3, 3, 3, 3, 4, 4, 4, 4. So 3 3s are 9, 9 3s are 27, 4 4s are 16, 16 4s are 64, 64 4s are I guess 256. Yes, 256. Now 7 6s are 42. No need to do another calculation. Listen carefully. No need to do another calculation. 7 6 are 42. In this case we have got 5. In this case we have got 2. Means C is my right option. No need to do anything. Some smart work you can use, right? No need to do all these calculations. So directly you will get the answers. Next question from thermodynamics. Match list 1 with list B. Delta G upon delta D at constant pressure, delta H upon delta B at constant pressure. I guess it is the match the following. Okay, we have got the 4 options. Now how you can solve this? Do not solve all the 4 options. Just solve this thing. B, delta H upon delta T at constant pressure. What is it? Cp means B1. Delta U upon delta T at constant V is Cv. B1 D3. B1 D3. Let us find. B1 means this is not our option. Not our option. B1 D3. B1 D3. Okay, we have got this thing. Means this is also not our option. We will go with the option number. So kids, this is the smart work that you can. Do not go for all 4. Whenever you have got this type of question in which there is match the column, just go for 1 or 2 options. No need to solve all the 4 options. Just get 1 or 2. If the other options are matching, then you can go for all 4. But generally, in you can say 95% cases, by picking only 1 or 2 options, you can solve all the question. You will get the right answer. So moving towards next. Identify the homoelectric complexes that are low spin. Low spin complexes means strong field. Strong field means A is not our option, right? It is okay. Cobalt in +3, except fluorine, it always make strong field complex. Means COF3, it will make weak field complex, right? So if I check the options, option A is gone. Okay, means C is not my right option. C is not my right option. This is not my right option. So I have got with C and D. Cobalt with +3 means definitely C. C and D. Why? Because cobalt with +3 always, if you remember the concept and the trick. So we have got the right answer once again, right? Exceptional cases are used for cobalt. Both exceptional cases for cobalt has been used here. These are the things you need to remember. CFSE, everyone knows how to solve CFSE, how to fill the electron, but exceptions must be remembered. Next, RBr Mg diether H2O 2-methyl butane. Hydrocarbons class 11 Zhutenov reaction. If you remember, Grignard reagent with anything which gives protons gives you alkane, if you remember. So that is the type of question. So what we are getting, the maximum number of RBr producing 2-methyl butane by above sequence of reaction is, okay, means the reaction may have been proceeded like this. RBr plus Mg diether, then it would have given you RMgBr, then H2O, it would have given you RH. This is the Zhutenov reaction. Everyone knows Zhutenov reaction. Now we have to find the number of RBr. Definitely R is this, because only we have removed the bromine, we have included the hydrogen, we have replaced hydrogen and bromine in this lecture. So I can make the isomers. It is saying that consider the structural isomer, means you need not to solve the stereoisomers. Remember, when you have to find the stereoisomer, when you need not to find stereoisomer, it is mentioned here. So I can make the isomers from here. First I can make here bromine. Second I can make here bromine. Third I can make here bromine. Fourth I can make here. Now if they would have asked the stereoisomers, it would have increased by optically active carbon, bro. Optically active carbon is there. Here again the same thing. So they have asked only structural. Always remember, if they have asked that the give us the maximum number of RBR producing, then you have to include stereo and structural. But they have specifically mentioned here, so I will go with 4 if it is an option. Yes, C is there. That is again the right option. So this is how you can solve. Means you have to. This question looks like. This question has a mixture of isomerism as well as the chemical reaction, Zutanov reaction, hydrocarbon. Both chapters have been mixed in this question. So alkane from below having 2 secondary hydrogens, we have to make all these structures. No trick to find this thing. Tetramethyl heptane 2, 2, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2, 2, 4, 4. Methyl 4, 5. 1, 2, 3, 4, 5. Tetramethyl heptane, the alkane from below having 2 secondary hydrogens. We have got primary. So if I got hydrogen, we have got 2 secondary here, but we have also got the primary hydrogen. Means first is not my option. 2, 2, 4, 4 tetramethylhexane. So I'll change the color better. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 2, 4, 4. CH3. 1, 2, 3. Okay, not here. CH3. I have got 2 secondary. The problem is I have got the primary also as well. So that is not again my option. Then if I go for the third option, 3-ethyl dimethyl octane. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, 1, 2. 4-ethyl. 1, 2, 3, 4. 4-ethyl C2H5. Then 3, 4 dimethyl. 3, 4. Okay. CH3 and CH3. I have got the tertiary also, means this is a definitely then 4th is our right option. Let us draw this structure also. In these 3 options, I have not got whatever they have asked for. So let us draw the last structure. 2, 2, 3, 3 tetramethyl pentane. 1, 2, 3, 4, 5. 2, 2, 3, 3. CH3. And CH3. The alkane from below having 2 secondary hydrogens. So one is here and one is here. These are the 2 secondary hydrogens. So definitely option number B is my right answer. That's how we got this answer right. So structure based. Now next question. Okay, chromyl chloride, carbon disulfide. In the presence of carbon disulfide, toluene is there. So you tell me which reaction is there. It is a naming reaction. Now you have to react the product with sodium bisulfite. So just we have to check the options. If the options are there, you will get the hint from the options. If something is specific, then no need to solve this question as well. You can directly solve it. So if option number A, we have got okay, C and D. Now if you see clearly, option C is my right option. How I can say, if you remember the reaction of aldehydes or carbonyl compounds with sodium bisulfite, intramolecular hydrogen exchange with sodium atom. No need to go for residue or something else. No need to do anything, because aldehydes on reaction with sodium bisulfite gives us this product. Right? If you remember, then definitely I'll go for C. C is my right option. This is a tricky question. No need to use the concept as well. Just go for the options if something is different and you remember that this happens Just solve it, then we got the right answer. Next, an element in the extreme left of the periodic table forms acidic oxide. Extreme left means, if I draw the periodic table, extreme left side there are metals and right side there are non-metals. Means if metals, okay, metallic oxides are always, they are basic in nature, right? Metallic oxides are basic in nature, and non-metallic oxides are acidic in nature. That means the statement 1 is false. Acid is formed during the reaction between water and oxide of a reactive element present in the extreme right of periodic table. Extreme right means non-metal, means definitely statement 1 is true, false. Statement 2 is true. 1 is false, 2 is true. 1 is false, 2 is true. 1 is false, 2 is true. Got the right answer. Basic concepts. Use your NCERT textbook. Use your basic concepts. If you use these basic concepts, you will get all the answers right. So species which do not undergo disproportionation reaction in redox reaction, we have studied that disproportionation reaction is shown only by those species whose oxidation state is in between maximum and minimum. Only those species show disproportionation reaction. If the oxidation state is maximum, it cannot show disproportionation reaction. If it is minimum, it cannot show. So just calculate the oxidation state. Here I have got chlorine is showing +7, +5, +3 and +1. So definitely A is my right option. Why? Because the oxidation state of halogens goes from -1 to +7. This is the maximum. So I'll go with the option number A. Got the right answer, right? So next, a spectral line will be observed from a 2px 2py transition. That is a wrong statement. Why it happens? Because if you remember, in hydrogen spectrum we have studied that the spectral lines are only formed if electron jumps from first state to another state, second state to third state to fourth, or it is jumping from 4 to 3, 3 to 2, 2 to 1, means depending upon the absorption or emission spectra, right? So spectral lines, this is a wrong statement. 2px and 2py are degenerate orbitals, it is right. Both are degenerate orbitals. So means 1 is false, 2 is true. 1 is false, 2 is true. Option number A is there. Got the right answer. Just basic concept. We are not using the JEE, means high level concepts. We are not thinking about. Okay, match the column. Now again I am telling you, no need to go for all 4. Just pick the one option here from here. Okay. Let us suppose I don't know what will happen to this. I don't know what will happen to this. I don't know what will happen. Okay, if I see closely, now if there are 2 options that can give you the hint. 2 options. Which 2 options? Nitrobenzene and arsen. This is Mendel's reduction. If you remember, this nitrobenzene reacts with SnCl, giving us aniline. In 22nd January morning shift, there were 2 questions in which nitrobenzene reaction with SnHCl was given in there. So just go for B4 C2. C2B4. C2B4. C2. Okay, only one position we have got. Once again, that is the trick. Using your memory, using the trick. Now, how much time does this question took? Only 30 seconds maximum. We have got 25 questions in chemistry. If it takes approximately 1 minute to solve per question, you can solve chemistry in 25 minutes. Then 35 minutes you can utilize in mathematics. Although mathematics is not my subject, but the JEE result comes out of all the 3 subjects. You can utilize this time in physics. Mathematics, the questions are very lengthy. You cannot solve all the mathematical questions in 1 hour. You cannot solve. It is not possible. So you need to extract time. Chemistry gives you time. Chemistry gives you extra time. Chemistry gives you extra marks that you need. Next. Okay, this question is done. Going for the next question. Integer type question. Consider the following cases of standard enthalpy. Okay, this is given the magnitude of delta H, H2C6. It is very easy. So delta H R is equal to HR minus HP. Why HR minus HP? If you look closely, it is a combustion reaction. Heat of combustion, enthalpy of combustion is always positive or negative? Write in the comment box. It is always negative. Why? Because heat is eliminated, exothermic. That is the reason. So if I write for this thing, then it will become, let us put up the values. It is easy question. So just put up the values. How? It will be 2 into, what is the enthalpy of minus 393.5 plus minus of 3 into 286 minus of 1550. Now let us multiply these two digits. 393.5 into 2. So 5 2s are 10, 1 3 6 7, 9 2s are 18, 3 2s are 6 7. Means it will become I'll change the color better. It will become minus 787 minus 286 into 3. So 8 6 3s are 18, 1 8 is a 24 plus 25, 2 3 2s are 6, 6 to 8. So it will become minus 8 58. So this minus minus will become plus 1550. So it will be 8 7 8 7 8 7 15 4 1645. So it will become minus of 1645 plus 1550. So it will be 50 from here, 45 from here, minus 95. Now they have asked for the magnitude. Magnitude means you have to write the positive value only. So we have got 95 as answer. Let us put up. So this is how it is your NCERT question. Go and check your NCERT textbook exercise. Thermodynamics. It is mentioned there. So we'll go for with the 95 as my right option. That is the answer. Basic concepts again. No need to think at higher level. Next, complex Ni2 plus iron dimethyl glyoxime. Let us make first of all this concept and we'll look at the question. So nickel with the dimethyl glyoxime. So it is nickel. Dimethyl glyoxime means hydrogen. No, not hydrogen. It will be. Okay, I will. I need space. Okay, I will change the color. So it will be nickel CH3 C double bond nitrogen. It will make a coordinate bond. Nitrogen double bond C and CH3. Okay. Then we have got nitrogen C CH3, nitrogen C CH3. Here I have got OH. Here I have got O negative. I have got OH. I have got O negative. Now in this complex there is a hydrogen bonding between these two and between these two. Now the question is the complex of Na2 plus iron and dimethyl glyoxime contains number of hydrogen atoms. Can you calculate? How much are there? 3, 3, 3, 3. 4 3s are 12, 13, 14. If you know dimethyl glyoxime, it is not difficult task. The thing is you should know the structure. What is the denticity? How you can make the bond. So I have got 3, 3, 6, 6, 12, 12 plus 2, 14 as right answer. Got the 14 as right answer. Okay. Next question. Niobium and ruthenium have x and y number of electrons in their respective 4d orbitals. The value of 4x and 4y. So if you remember the electronic configuration of niobium, it is krypton 4d4 5s1 and ruthenium it is krypton 4d7 5s1. So x is equal to 4, y is equal to 7. What we got? 11 is the answer. Where you will get this type of easy questions? 11. The right answer. Okay. Next. 20 ml of 2 molar NaOH solution is added to 400 ml of 0.5 molar NaOH solution. The final concentration of the solution is volume of mixing. What is the formula of volume of mixing? Equilibrium chapter. M1 V1 plus M2 V2 upon M3 V1 plus V2. Very easy. So just apply the formula. M1 V1 plus M2 V2 is equal to M3 V3. So I can put it M1 V1 plus M2 V2 upon V1 plus V2, or I can say that it is my V3. So just put up the values. What is the value? 20 into 2 plus 400 into 0.5 divided by 20 plus 400, 420. So it will be 40 plus 400 into 0.5, 200 divided by 420 means 240 divided by 420. Cut these. So it will be 6 4s are 24 and 7 6s are 42. Now 4 divided by 7. Decimal 35.57. So write the concentration of solution is 10 to 1 minus 2. Okay, let me solve. It will be 40, 550, 49, 1 means it will be 1. So no need to round off, it will be 57. The answer is 57 definitely. We got the right answer. This is how you can solve the questions. Just you should remember the formula. That's why chemistry these days is becoming very easy for JEE NEET. But the thing is, you should know formula. You should know the tricks. Next we have got the compound with molecular formula C6H6, which gives only one monobromo derivative, takes up 4 moles of hydrogen per mole for complete hydrogenation, has dash pi electrons. Now we have got 2-3 hints. Only one monobromo means you do the bromination from every side, every aspect, it will give the same product, monobromo. You do the naming from this side, you will get the same name. It will take up 4 moles of hydrogen. This is the biggest hint here. Now let us discuss. Many students thought C6H6 that it is a benzene. Many students thought this thing. It is benzene. Now you tell me, does this benzene consuming 4 moles of hydrogen? You tell me. It is not consuming, it is consuming 3 moles, means this is not my option. Second option I can make like C, 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 C. Double bond, double bond, double bond. So because this benzene will give you monobromo, it will give you bromobenzene wherever you attach the bromine. In this case, if I attach bromine here or bromine here, I will get the same name. There is no difference in the naming. But does it consume 4 moles? No, it consumes only 3 moles, means this is not my option. So what else I can draw is 1, 2, 3, 4, 5, 6. I can draw triple bond, I can draw triple bond. Now if I do the bromination here, or if I do the bromination here, I am getting the same monobromo product. Right? Means this may be our option. So 4 moles hydrogen means it must having 4 pi bonds. So if I calculate 1, 2, 3, 4, yes. So this is the pi bond. Means 4 pi bond means 8 pi electron. Let us check. 8 pi electrons. 8 pi electrons. So this is how you can solve your question paper. Directly 4 mole of hydrogen. What is the hydrogenation reaction? It is very simple. You could have solved it directly. The hydrogenation reaction, 1 pi bond consumes 2 hydrogen or 1 H2. It is consuming 4 mole of hydrogen, means 4 H2. 4 H2 means 4 pi bond, that means 8 electron. Trick. This is the trick. The first one was the concept. So this is how you can solve. You can do everything by mixing tricks and concepts for this. So thank you very much for watching this video. This is how you can solve. I don't think that it would have taken for 30 to 40, more than 30 to 40 minutes, because I was explaining this, but you would have solved this within 30 minutes or 35 minutes. So kids, we will see you on the other side of camera in the classroom, and will come with the next video, 23rd January morning shift. So please share, like and subscribe my channel. Thank you very much.